Shall we start now? Write the heading graph. Now, in motion in 1D, we are having three types of graph: xt, then vt, then et. Xt is nothing but displacement time graph, or this is also called as position time graph. Then vt, velocity time graph, or at, that is acceleration time graph. Okay. Before learning all these three types of graphs, we need to understand the basic: when should be slope negative and when should be slope positive. Got my point? Okay, let us try to understand this. Okay, can I say this is your y-intercept? Positive, negative? Okay, positive c. Can I say this one is negative c? Okay, slope is positive, negative? Slope is positive, negative? Negative? Acha. If I write the same diagram like this, now slope is positive, negative? Depend on theta, na? It depends on what? Theta. Can I say that if this theta is greater than 90 degree, can I say m is negative? Can I? Or over here, theta is less than 90. If theta is less than what? 90 degree, then can I say slope is positive? Can I say that? Achha. Then, can I also say that this one can be written as y is equals to minus times of mx plus of c? Can I? And for this one, y is nothing but minus of mx, or for this one, y is equals to minus mx minus of c. Can I? Okay. Similarly, for these three, can I write y is equals to mx plus of c and y is equals to mx, and for this one, y is nothing but mx minus of c. Kya ghatiya chopis laye re. Okay. So these are the things we should be knowing. On what basis we can say slope is positive or negative? That is theta. If theta is greater than 90, m is negative, and if theta is smaller than 90, m is positive. Y-intercept and that it can be positive, it can be negative. The next thing, we need to understand, what do slope provides? Slope provides dy upon dx, na? Dy upon dx. Can I also say that slope is also equal to tan of theta? Can I also say that m is nothing but tan theta, or it is also written as dy upon dx? Can I write like this? Can I? Okay. I got my point. These are the basic things we should be knowing. Okay, write down. First one. Okay, no one will be writing. Everyone, focus on the board now. Shall I? Consider this is your x-axis. On x-axis, time is given, and on y-axis, displacement is given. Then can I say this is nothing but xt graph? Can I say that? And this is your origin. Everyone knows this. If I represent like this, a straight line, let this point be x0. Okay. At x0, do position of object is changing. At t is equals to 1 second, object is at x0. At t is equals to 0, object is at x0. Or t is equals to 2 second, object is still at x0. At t is equals to any time, object is at x0. That means, can I say that this bird graph represents the body is at rest? So here, can I say this graph is for rest? If body is at rest, what is the velocity? 0. And what is the acceleration? Can I say 0? Yes or no? Similarly, don't write anything, please. Similarly, consider like this, and this is your t, this is your x origin. Okay. Now this one is maybe traveling equal distance in equal interval of time. If unequal distances are traveled in equal interval of time, then can I say that body is taking or traveling with different speed? If body is traveling with different speed, then I can call this at acceleration. Yes or no? So before finalizing this one is moving with constant velocity or not, we need to check what? The slope. Okay, how to check the slope? Let me draw one line over here. Can I say this is your theta 1? Can I? Similarly, consider this is your theta 2. Consider this object is going further away and consider this is your theta 3. Okay. From this representation, can I say that these two are parallel to each other, these two are parallel to each other, all are parallel to each other? Can I also say that theta 1, theta 2 and theta 3 all are equal? Yes. If theta 1 is equals to theta 2 is equals to theta 3, then can I also write like this? Tan of theta 1 is equals to tan of theta 2 or is equal to tan of theta 3. Okay. What do M provides? First thing, M is positive, negative. Greater than 90, less than 90, less than 90. So if theta is less than 90, then M is your positive. First thing we should be knowing. Yes or no? What do M provides? M is nothing but dy upon dx. Yes or no? Who is on y-axis? X. Who is on x-axis? Time. Then can I say that this M is providing you dx upon dt, and dx upon dt is nothing but velocity. And what kind of velocity? That is nothing but instantaneous velocity. So xt graph, slope provides you instantaneous velocity. If this is the instantaneous velocity and we are saying that those instantaneous velocities are equal, theta 1 is equals to theta 2 and theta 2 is also equal to theta 3. That means, can I say that at this point, let's say v1 is the velocity at this point, theta 2 and v3 is the velocities. So can I say that v1 is equals to v2 is also equal to v3, which all are equal? If all are equal, then can I say it is nothing but constant? Nothing but constant. If velocities are equal, we are saying constant, then what is the acceleration? 0. Yes. So acceleration over here is what? 0. If acceleration is 0, can someone tell me where the body is going? Towards positive x-axis. So can I say that body is moving towards positive x-axis. Do this diagram also provide something else? Can I say that body is traveling equal distance in equal interval of time? Are I got my point? So to represent that, can I represent like this? This is the distance, this is the time. So similarly, can I say that this is the distance and can I say that this is the time? So body is traveling equal distance and equal interval of time, as we all know that if velocity is constant, that will be happening. Are you got my point? Note down now. Third one. Okay. This is your x, t, origin. Now listen to me. Stop writing and listen to me. At t is equals to 0, where is the object? Let this be x naught. At t is equals to 0, where is the object? At x naught. Okay. Now first thing, before saying anything, can I say body is traveling towards a negative x-axis? Maybe moving in this direction, positive x-axis. Body is moving in negative x-axis. Let us try to understand why I am saying this. First thing, let us say slope, calculating the theta. Can I say this is your theta 1? By checking this is your theta 2. Can I say this is your theta 3? Again, these three dotted lines are parallel to each other. If they are parallel to each other, theta 1, theta 2 and theta 3 are equal to each other. So can I say theta 1 is equals to theta 2 is equals to theta 3? Can I say that? Okay, can I also say that tan of theta 1 is equals to tan of theta 2 and it is also equal to tan of theta 3? Yes, slope is negative or positive? Theta is negative, greater than 90 or less than 90? Yes, greater than 90. So theta is greater than 90. Then can I say m is negative? M is negative. If m is negative, then can I say that velocities, by seeing this theta 1, theta 2 and theta 3, velocities are equal to each other. So v1, v2 and v3 all are equal to v, and this v is constant. Are yes or no? Okay. If velocity is constant, what is the value of acceleration? Acceleration is 0. Can I say that? Okay. Now where the body is moving? Where the body is moving? Body is moving towards negative x-axis. Why? Because our slope is negative. I got my point. Velocity, speed is not changing. Body is moving in the negative direction. In the last diagram, in I think second graph, body is moving in this direction. Now the body is moving in this direction. Over here velocity is constant in the last also, but it is moving in what? Positive direction. Let me write the direction also and write the direction in the second one. Velocity is positive. Over here write velocity is negative. Velocity is negative. Okay. So here the velocity is negative. Why it is negative? Because it is moving towards, consider this is your origin, this is your x. It is moving in the positive x direction. Consider this is your origin and now the body is moving in the negative x direction. Okay. It doesn't mean that velocity is negative means it is changing. Body is moving towards the negative x axis. That's the reason slope we got negative. And I got my point? Okay. Right on. Next one. Fourth, body is moving like this graph. So this is your x, again this is your t. At t is equals to 0, x is 0. Shall I know? Now, whenever the diagram is given in curve form, you need to draw what? Tangent. Okay, so if I am selecting one point and I want to draw a tangent, can I say this is the tangent? Okay, and can I say this is your x-axis? Can I say that this is your theta 1? Okay, similarly I am selecting one more point here and I am drawing a tangent. If this is the tangent, then can I say that this is your theta 2? Similarly, let's select one more point here and can I say that over here is your theta 3? Okay, theta 1 is in theta 1, theta 2, theta 3. As the curve is going in this direction, can I say that theta is increasing? Theta is increasing. That means can I say that theta 1 is smaller than theta 2 and it is smaller than theta 3? Yes or no? And can I also say that tan theta of 1 is smaller than tan theta 2 and it is smaller than tan theta 3? Can I say that? Achha. Before finalizing where the object is going, we need to check the slope. First thing, theta is greater than 90 or less than 90? Yes, theta is less than 90. That means can I say that slope is positive? If slope is positive, definitely object is going in the positive x-axis. Okay, now, so body is going in what direction? Body moves towards positive x-axis. Okay, well, what about velocity? Can I say that v1 is greater than v2, v1 is smaller than v2 and smaller than v3? Yes, as this curve is representing, the velocity is increasing. Velocity is increasing. If velocity is increasing, what is the direction of velocity? Positive now. It is moving in the positive slope. So velocity is what? positive. If velocity is positive, what is the direction of acceleration? This is the direction. Okay, so velocity is positive means direction of velocity is towards positive side. Okay, where will be the direction of acceleration? First thing, acceleration will be there or not? Yes. Why? Because velocity is changing, it is increasing. Yes or no? So definitely there will be an acceleration, and whenever the body is moving with increasing velocity, we all know that the direction of velocity and the direction of acceleration will be in the same direction. So can I say that acceleration is also positive? So can I represent that this is the direction of velocity and this is the direction of acceleration? Similarly, direction of motion. Everything is moving toward the positive side. Acha, one more thing. Can we say that this acceleration is constant? Maybe variable. Yes. So we cannot say over here acceleration may be or may not be constant. So we cannot say acceleration is constant or not just by seeing xt graph. To say this one is constant or not, we have to follow vt graph. Okay, right on. Fifth one. Now listen to me. So your t, this is your x, 0. Shall I? Now, everyone close the book and just listen to me now. Let me select a few points first to draw the slope. So this is your point 1 and consider this is your point 2 at center and over here and over here. What we need to draw? Tangent, yes. So drawing the tangent, can I call this as your theta 1? Yes. Okay. Again drawing the tangent here. Can I say this is your theta 2? Theta 1 is greater or theta 2 is greater? Theta 1, na? Okay. At this point there will be no slope. So over here theta is 0. Okay. Similarly, again drawing the tangent. This is your, let's say this is theta 3, theta 4. Again at this point drawing the tangent. This is your theta 5. Okay, and let's say this is your point A, this is your point B, and this is your point C. Now, everyone listen to me. Let us discuss with A to B. First, we will discuss about A to B. Theta 1, theta 2, then 0. Are yes or no? First thing, tell me what about theta 1 and theta 2? Can I say that theta 1 is greater than theta 2? Yes or no? Then can I say that tan of theta 1 is greater than tan of theta 2? Can I say that? Yes? Okay. Now, what about slope? Positive, negative? Yes, positive. So theta is less than 90 degree. Definitely m is your positive value. Okay. If m is positive, that means where the object is going initially? Positive side. Okay. So can I say that velocity is positive? No. Theta 1 and theta 2, who is greater? Theta 1. That means as I am moving in this direction, velocity is increasing or decreasing? Yes, decreasing. So velocity is decreasing. Velocity is what? Decreasing. M is positive, na? M is positive. That's the reason can I write velocity is positive. Velocity is positive. And what about acceleration? velocity decreasing. Now come back here. If a body is going in this direction, it is going in the positive side direction, but velocity is decreasing. Whenever velocity is decreasing, then the direction of acceleration is opposite to the direction of motion. Yes or no? And velocity is in positive side. So velocity is towards positive side. Definitely acceleration will be going towards the negative side. Are yes or no? So what should I write over here? Acceleration is negative. If acceleration is negative, then it is called as retardation, deceleration. Are yes or no? Yes, whatever you wish, you can write. Now, at this point, velocity becomes what? 0. Then at B, velocity at B becomes what? 0. I got my point till here? Okay, then now let us find what is happening beyond B, that is B to C. Okay, now first tell me what about slope. These two angles, that is theta 4 and theta 5, is greater than 90 or less than 90? Greater than 90, yes or no? So from B to C, theta is what? Greater than 90. That means, can I say M is negative? M is negative. If M is negative, then slope is negative. Then slope is negative. That means, can I say that body is going towards what? Negative side. Are M is negative na beta? If M is negative, definitely velocity is in the negative direction. If it is increasing or decreasing, let us find. Now by seeing that, we can say that theta 4 looks like greater than theta 5. Just by seeing, by observing this diagram, I can say that theta 4 is greater than theta 5, but we got a slope of negative. Whenever slope is negative, tan comes in second quadrant. Yes or no? If tan comes in second quadrant, then for example, consider this one, we got an angle of 30 degree, this one is got angle of 45 degree. Then we consider only what? Magnitudes. If we consider magnitude, that means being the smaller angle, it will be having a greater value, and being the greater angle, it will be having smaller value. I got my point? Okay, so from B to C, can I say that theta 4's magnitude, if I consider theta's 4 magnitude, is smaller than theta's 5 magnitude. Okay, got my point? You will be getting a negative here and negative here. That's the reason I am considering only what? The magnitude. Then can I say that tan of theta 4 is smaller than tan of theta 5? That means, can I say that velocity of 4 is smaller than velocity of 5? What is happening in reality? Velocity is increasing. So from B to C, velocity is increasing, and from A to B, velocity is what? Decreasing. I got my point? Okay, then can I also say that if V4 is smaller than V5, acceleration, positive, negative. Acceleration will be along the direction. Okay, where the body is going? In this direction. So velocity is increasing. But going in which direction? Negative direction. Yes, very good. So velocity is negative. If velocity is negative and velocity is increasing, then acceleration, yes, very good. So acceleration is also negative. I got my point? Yes or no? Okay, till here, any doubt? Now let us find whose representation graph is this. Can I say that this graph is representing either ground to ground, body is going in this direction, where G is acting, in reality where A is acting. If body is going in the upward direction, velocity decreases, we all know that. Yes or no? And acceleration is acting opposite to the direction of velocity. Sorry. Yes, this is the direction of not velocity. Velocity decreasing, but velocity is moving in the upward direction. Object is moving in the upward direction. ऐसा नहीं लिखते. Let us write motion. Better write in terms of motion. Now body is moving in the upward direction, so motion is in the upward direction, velocity decreasing, and can I say acceleration is acting in the downward direction. At this point velocity becomes 0. Are yes or no? Similarly, while returning back to the ground, direction of velocity is in the downward direction, that means increasing. Velocity is increasing, motion is in the downward direction, acceleration is also in the downward direction. I got my point. This M represent motion, just for understanding purpose. So M is in the upward direction, velocity decreasing, acceleration is in the downward direction. Okay, similarly over here, while returning back to the ground, can I say velocity is increasing, motion is in the downward direction, and acceleration is also in the downward direction. See here, acceleration negative, velocity is negative, both are in the same direction. That means they are returning from the peak, that means from H max. So here velocity is positive, that means body is going in the upward direction, but it is decreasing, but acceleration is in the negative direction. Can I also say that this graph also represent one more thing? If body is going in this direction with initial velocity, when it becomes velocity 0, then later it will be turning na. Are yes or no? We have done many questions on this turning point. Yes or no? In this direction velocity decreases, acceleration is in the opposite direction. Similarly, while coming in this direction, velocity is increasing, but acceleration is also in the same direction. Yes or no? Either understand by this or either understand by this. Okay? Note down now. Either like this or maybe like this also. They can provide you here also. This is one different diagram. Draw two different diagrams, one over here and the other over here. Okay, and one is in the negative x-axis, sorry, y-axis. Maybe it is going over here or not, maybe stopping here, whatever it may be. So initial time t is equals to 0, t, this is your x. Can I say both representing the same thing? Yes or no? But only the difference is, we will understand that also. Okay, first thing, selecting the, can I say at this point, velocity becomes 0. Why? Because theta becomes 0, slope is 0. Yes or no? Selecting one more point here. If I select one point here, drawing the tangent and the angle. So this is your theta. And let us select over here also one point, drawing the tangent, theta over here. So this is theta 1, this is your theta 2. Similarly, selecting one more here, drawing the tangent, and at this point let us select one more and let us say this is your tangent, theta. Okay, so this is theta 3, theta 4, theta 5. Same thing is applicable here also. Okay, draw the two tangents here, draw the slopes. At this point again slope becomes 0. Draw, select two more points here and put same things. Okay, now shall I? Let us say this is your A, this is your point B, and this is your point C again. Okay, now A to B, theta increasing, decreasing? Theta is decreasing, na? Slope negative, positive? Slope is negative. Okay, very good. So from theta 1 is, can I say that is smaller than theta 2? Sorry, theta 1 is greater than theta 2. Can I also say that tan of theta 1 is greater than tan of theta 2? Can I? Okay, by seeing that theta is greater than -90 degree, that means can I say that M is negative? If M is negative, definitely body is going in the negative direction. Okay. What about velocity? Decreasing, increasing? Yes. So can I say that V1 is greater than V2? That means velocity is decreasing. If velocity is decreasing and it is going towards which side? Negative side. Okay. So velocity is having what? Negative. If velocity is going in the negative direction, velocity is also decreasing, then direction of acceleration will be opposite to the direction of motion, na? Yes or no? That means, can I say that acceleration is positive? By saying that acceleration is positive, that means body is accelerating or retarding? Retarding, yes. Not by seeing these directions, negative and this positive, again and again I am telling you, these are just the direction. How we are saying that body is retarding or accelerating? By seeing the velocity. Here the velocity is decreasing, that the reason I am saying that acceleration is having a negative value, that is negative acceleration, that is retardation. But the direction of acceleration is towards positive. Why? Because direction of velocity is towards negative. I got my point. Similarly, at B, can I say that it is 0? At B, velocity is what? 0. Similarly, from B to C, again theta is increasing or decreasing? Again, you have to select the magnitudes. Are yes or no? That means, can I say that from B to C, what is the value of this M? M value. Theta is less than 90, greater than 90. Yes, less than 90. So from B to C, theta is less than 90. Then can I say that M is positive? If M is positive, definitely the body is going towards positive side. So can I say that theta, 4. So theta 4 is smaller than theta 5. That means V4 is smaller than V5. Can I also say that velocity is increasing? If velocity is increasing, what is the direction of velocity? Positive side now. So velocity is what? Towards positive. It is increasing or decreasing? Increasing. Then what will be the direction of acceleration? Positive. So acceleration is positive. This time body is retarding or accelerating? Accelerating. Yes, very good. समझ में आ गया मतलब. Okay. So these are the basic things you should be knowing to find the numericals on XT graph. Okay. Same thing you can apply. What you have applied here, you have to apply here. Okay. But there will be a slight change in slope. No. Slope is also over here negative. From A to B, slope negative. From B to C, slope is positive. Same representation. Just I represented this one in positive coordinate, this one in negative coordinate. Okay. अब ये positive plane है ना, both x and y both are positive. Here x is positive, y is negative na, nothing will be happening. Okay. Explain yourself. Write example number 1. After completing example number 1, we will move to VT graph. Okay. Consider body started from origin. At this point, let's say displacement in 10 meter. Everything is in meter and seconds. Okay, then it comes over here. Consider this as your 5 meters. Then body moved in this direction. Then what happened is body moved in the negative direction. Then from here, it reached to here. Consider this is minus 5 meter. Okay, let us say the time periods now. 0 seconds. Here 2 seconds. And consider here 4 seconds. And then from here to here 5 seconds. Then later इधर कितना देंगे time? 10 seconds. Then 6, then 8. इसको 7 कर देंगे. Okay, consider this is your 6 seconds. Consider here is your 7 seconds and over here 8 seconds. Question is find find average velocity. First is from time 0 to 2 seconds. Okay, then 0 to 2 हो गया ना. Okay, then 2 to 4, from time 2 to 4 seconds. Third 6 to 8 कर दे. Okay, from time 4 to 7 कर दो. 4 to 7, here is the 7, so here is the 4. So time from time 4 to 7 seconds. Okay, come on, try now. First answer, one line answers only. What is between 0 to 2? What is the final position? Can I say 10? What is the initial position? So V average can be written as x final minus of x initial upon t final minus of t initial. Yes or no? Okay, so first answer is V average is equals to final position 10 minus of initial position 0, origin. At t is equals to 0, it is at origin now. So 2 seconds. That means, can I say 5 meters? Sorry, 5 meter per second. Second answer is from 2 to 4 second. Where is 2? So here is the 2. So this is your final position. Final position is at 5. So V average is nothing but 5 minus of 10 divided by how much time? Again 2, that is minus 5 meter per second. And the third answer is what? From time 4 to 7 second. So 4 is here, 7 is here. That means in 7 is here now. So from 4 final position is minus 5, initial position is 5. That means V average for this one is final position is minus 5, initial position is 5 minus 5, and total time is 7 minus of 4, that is 3. That is nothing but minus 10 upon 3 meter per second, that is 3.3333, so on. Okay, now write the heading VT graph.